Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today, in this video, we are going to see about electrochemical power sources. I would like to begin by raising few questions. How do you power your favorite device at home? It's either phone or remote. So of course, we use batteries for that. When your smartphone or the TV remote it stops working, what do we do? We charge them. Okay, what about the remote batteries? Do we recharge them or do we throw it away? So to empathize this, we have to know that is the device or the cell that is running your favorite devices at your home. And also the very good example is your cell phone. Here the chemical energy is converted into electrical energy. That is phone is charging. So when you're disposing your batteries that is present in your remote. So these types of batteries are the primary batteries. We cannot recharge. But your recharging, that is your cell phone, that is your smartphones, cameras, wireless headphones, all these things. So they are the secondary batteries. So batteries convert stored chemical energy into useful electrical energy. The global battery market is rapidly expanding. So it is expected to reach $200 billion by 2030. This is a rough estimation that is made. And batteries are vital for the portable electronics, electrical vehicles, and renewable energy grids. So just imagine you're going for a trekking, you're going out. So a portable, rechargeable device is necessary. So all these comes under the emphasis of usage of the rechargeable batteries. So what are electrochemical power sources? How do we define them? So as I already said that the converting chemical energy to electrical energy, and this is through the redox reaction. So what's the principle involved in this? In anode, oxidation takes place by releasing of electrons. In cathode, rejection accepts electrons. So there are different components that is present here. To be mentioned are the anode, cathode, electrolyte, separator. All these things they work together to form a battery. So electrochemical power sources, they are defined by the ability to convert the chemical energy into electrical energy to reduction, oxidation reactions. So how do you identify the real world problems? So this will define your problem. That is, you need a electrical power source, either to take your cell phones with you, to use the remote and the cell phones or cameras that is in your house, to recharge your electric vehicle. So the real need for portable energy, that is charging gadgets on the go. It's popularly said like this. So why do some batteries run after a single use while other can be recharged? So this will define you about the primary batteries and the secondary batteries. So TV remote, they usually uses the usable, that is disposable batteries, which are the primary. Smartphones, of course, you all know you use the rechargeable batteries. They are the secondary batteries. So these electrochemical power sources, they consist of an anode, it's a negative electrode, a cathode, a positive electrode, an electrolyte for the ion conduction, and a separator. So these, it is in a good example is a Daniel cell. It just gives a voltage about 1.1 volt. So let us see a few terms about the key characteristics. That is cell voltage. It is the potential difference between the anode and the cathode. It's nearly approximately zero point 0.5 volt to 4.5 volt. The nominal voltage is the operating voltage, that is from 1.5 volt for alkaline AA batteries. These batteries, they are in series and we use it in the remote. Open circuit voltage, the voltage when no current flows higher than the nominal. System voltage, cell connect in series, adds voltage or parallels adds capacity. So if cells are connected in series, it adds the voltage. Or if it is added in the parallel, it adds the capacity. So voltage is something which is a critical characteristics of an electrochemical power sources. Cell voltage will range from approximately 0.5 to 4.5, while the nominal voltage represents the average operating voltage. So when you take, that is, batteries can be configured for a system voltage by connecting cells in series to increase the voltage or in parallel to increase the capacity as we saw earlier, such as 12 volt car battery with 6 2 volt lead acid cells. So ideate, that is, explore the solution, that is, if you have to improve how long your remote or the phone works. What ideas do you have? Would you prefer a reversible battery or a reusable battery? Imagine you have a circumstances where you are making a battery for a flashlight that is on a hiking a trip. What would be the important one over there? Just guess it. It will be the batteries. It should be lightweight. It should be long lasting, and also the safety concerns are there. Okay, now we're just telling about the primary and the secondary batteries. So compared to a single use and reusable shopping bags. When you compare it, the reusable, it will be a comfort one. See, we have to consider the environmental factors too. Next is the battery capacity. So for example, if you take a water bottle, a small size of water bottle, how much capacity it will hold the water? Just to a less extent. If you take a larger one, you'll have a larger extent. Similarly, remote needs just 1.5 volt of AA battery. But cars, it needs 12 volts. That is, you should have multiple cells. So this is the idea behind of making or using a battery for one particular application. So the concept over here is the chemical energy to electrical energy. So in everyday use, we use phone charging. Primary batteries, we use TV remote, wall clock. Secondary batteries, we use smartphones, camera, wireless headphones. So battery capacities, we are compared with the water bottle. Series connection, 6 to, that is, you have the size of AA batteries for a toy, etc. Parallel connections, two power banks to recharge your phone. So this parallel connection, this will give you, that is, it has a higher capacity. Series connection, you have higher voltage. So self-discharging is when you keep the battery for a very long time, it will just start discharging by itself. It will be compared to when you blow a balloon and keep it aside without using it. After a few days, the air will be flown out. Okay, so now we'll just see about the key characteristics, that is capacity and power of a battery. So this is a very important term, that is the capacity is given in amp hours. 2500 amp hours, 9.25 watt hours. Watt hours, it gives the energy. That is, it's a more accurate comparison. Calculated as voltage multiplied by amp. C is the rate, defines the discharge or the charge rate relative to the maximum capacity. Power watt signifies the rate of energy delivery, crucial for high drain applications like power tools. So from here, you just imagine our battery innovation. That is, it has to live longer and it should be eco-friendly battery. So we have to find the technique to get a battery which meets these particulars. Thank you.